Everyone, and welcome to the 8th episode of the L-DIH Talks. My name is Ivan, I'm support officer at the Digital Innovation Hub. And for today's topic, we have rapid IoT prototyping. And welcome our speakers. Both are from the Luxembourg Institute of Science and Technology. So we have Laurence Johansen. She's a researcher, and she will briefly introduce you to the test before invest services of the L-DIH. Sorry. And we have Christian Moll. He's senior engineer, and he will present you the main topic of today. And just before we begin, there is a question tab in the chat. Feel free to drop your question there anytime. We will address them in the Q&A at the end of the session. So I give the word to Laurence. Hello, Laurence.
Good morning, everyone. I will put my slides on. Nice to see you for this new L-DIH talk, our Friday routine. Today we're going to talk about rapid IoT prototyping for the industry. First of all, let me give you a brief introduction about L-DIH. For those who didn't come and see us at Nexus this week. So we are a network of partners, Lux Innovation, University, House of Cybersecurity, and LIST. And we are dedicated at supporting the digitalization of industrial SMEs. For this, we have 4 types of services that we design for you. And we are responsible for the test before invest services. So we put at your disposal all our testing facilities. We have a visualization wall to show and navigate within large-scale data sets. We have an immersive arena to run experiments, a car lab for testing autonomous vehicles, an extended reality lab, where some of you had the chance to visit last year. And we have a 5 and 6G lab. Here on the picture, you can see our booth for demonstrating it on Tuesday on our booth. But apart from those facilities that you can use, we also have some different activities that we propose for you to test technologies. The first one are the talks like this morning, where you could just discover some topics. Then you can go further during hands-on workshop and come and test some solution based on real industrial use cases. And then we have the digital opportunity scoping, where we support you into designing your tailored system. So the L-DIH talk like this morning, our Friday morning routine, is 1 hour where you can discover a technology, just like IoT prototyping this morning. There are many topics that we treat. You can see the list here, and all the L-DIH partners are contributing to these talks. Then we have the hands-on workshop, where you can come here at LIST in Belval and test some solution hands-on based on really industrial use cases. The next one will be on data acquisition and visualization on September the 25th. So you will see how to acquire and analyze data and build dashboard. Then we will have predictive maintenance. So that would be some AI modeling to do predictive maintenance on machines on October the 2nd. And we'll have extended reality to do training to industrial maintenance, UX design, and so on. And should you want to go further, we can provide you with tailored support, where we have working session together to improve your level of AI readiness and identify the best suited approach for you to leverage your data and support your business. And then we can provide you with an exploratory data analysis that is exploring how the fit for purpose of your data for your business problems. Or we can go for an L-DIH project and we can design it together so you build your own POC to experiment these use cases. But now, let's dive into our subject, rapid IoT prototyping. Why did we choose this subject? Because first of all, IoT is everywhere nowadays. From wearables, so smartwatches, fitness trackers, healthcare wearables, to smart homes. I'm sure most of you have your own personal Siri or Alexa at home, but it's also for retail shops and in healthcare and logistics to have smart shelves or connected medical devices, and up to smart cities. So the third picture here, cities who leverage, who use IoT infrastructure to leverage data to decarbonate or improve the life of their citizens. So these are large-scale systems connected with energy grids, transportation, and utilities. IoT is also everywhere in industry. It's about leveraging your data to increase visibility on your operations, enhance troubleshooting and your maintenance capacities, be it reactive maintenance or predictive maintenance. So it's an ecosystem of sensors, application, and networking equipment. Leveraging this requires for you to have network equipment, centralized connectivity, and strong cybersecurity. So you'll be able to collect real-time data, to monitor and analyze it on your industrial operations and monitor your activities, be it manufacturing, production, and maintenance. The benefits for you would be to improve the reliability of your equipment, to maintain the quality of your product, to enable predictive maintenance, to reduce unplanned downtime, and to optimize resource and energy usage. But also, it's not only for production, it can also help you to ensure regulatory compliance, to improve the safety of your workers, to improve your customer experience, and to support data-driven decision-making as a whole. As usual, it all starts with data, and here are some examples of the data that you can collect and analyze to achieve the different benefits talked before. So they can be data at the machine level, like temperature, what we will show you today, pressure, valve position, vibrations, etc. It can be related to your product as well, and it can be environmental and linked to safety. But now I will leave the ground to my colleague, and he will give you a brief introduction about IoT protocols, and then he will show you a real experiment and how you can acquire time series data with a no-code interface and build the dashboard with another no-code tool. So I give you Christian more.
Now let's go into the technical part of this webinar. First, I'd like to talk about protocols. So I made you a very condensed list of available IoT protocols, and I separated them in 3 categories: more the IP-based, LAN, Wi-Fi, Ethernet-based protocols like MQTT, or HTTP REST, which is mainly used for server communication or for edge devices that can communicate with a server. In our webinar, I will more focus on MQTT. It's a very lightweight protocol and it uses a publish-subscribe. As more common in machines and already quite old, you will find there are a lot of devices that use Modbus or CAN bus. They are both serial field bus-like protocols, and yeah, they are very established, very simple, quite robust in the industrial environment, so they can work with higher voltages, they can last interference, and they're really made for harsh environments. The drawback is, beside the Modbus, that there is a variant that is using TCP. You always need another device to connect it to the internet. As a third category, I would point out or look into the low power wide area networks, which is, for example, LoRa or LoRaWAN, which is a very low data rate protocol that's only useful for small amounts of data, but you have the advantage that they last long because of their small energy consumption. So you can run them easily on battery for years. On the other side, there is the cell phone-based systems like NB-IoT or LTE-M, which use the mobile networks, which gives you the advantage that you can use the good coverage of the mobile infrastructure. But today I will focus more on MQTT, and MQTT uses a publish-subscribe approach. So you see here, you have some clients that could be a sensor or a machine that publish something to a device in the middle, which is called MQTT broker. And yeah, it could be everything from temperature, humidity, pressure, RPM values, voltage, or whatever you want that is published to the broker. On the other side, you see as well MQTT clients, but they are also subscribing to the broker. And the subscription is always made to a topic. So let's explain or look into what a topic is. It's a kind of namespace. It looks like written here. It's a structure which is separated by slashes. And the sensor is normally always emitting a payload. This payload can be a number or text or even a JSON message. And all the communication is managed by the broker. Let's look into an MQTT broker, but first I want to check if my MQTT server is on. So you see here I have running a Mosquito server here on port 1883 on a Docker machine. And I now like to make a first look into what is happening on such a server. So I connect here with a tool called MQTT Explorer to my local test server, and you see there's quite less things that are happening. So I have here root access to this server. So we see also some system messages. So how many clients are connected? In the moment, it's only 2. And I will now enable one sensor, and we will start to see that something new is happening on the server. So you can see here now, we have our first device that is connected, that is emitting something on a topic that is called fake device / random temperature. And you can already see here, it's transmitting numbers, float numbers. And what's a cool feature of this tool, you can also plot. If you have numerical data, you can plot it. This gives us a first easy approach to get in touch with data, get a bit of overview of the data, and yeah. So let's go back to the presentation. And as another more fancy system, I like to show you Shifter, which is a web system that can also show us what is happening on an MQTT broker. You see here in the center, this is also a broker. That's the broker of Shifter itself. And I use Node-RED to forward all messages that are coming to the broker. So you see here, there's really already happening a bit. So we see our fake device with the random temperature, and we can also look into the data here. But it's also nice to show a bit more of data to get really a view on what's happening on your broker. So I now made a route to our lab server. It's now showing way more data. So we have here incoming data from a photovoltaic installation of a colleague. We have here sensor data from the sensor network in our labs. So there are different labs, different devices that are connected here to our broker. So next I want to talk about how we get the data and how we can visualize it in a more useful way. For this, I want to give you some software names that you can use for brokers. For example, as running here in our webinar system, we use Mosquito, which is an open source broker, which is very lightweight. It's only a few megabytes if you want to run. I think it's the Docker container itself is 6 megabytes or something. That can be run by you on your premises or on a cloud service. As another broker, I can really recommend HiveMQ, which is a cloud-based broker. You can host it yourself, the community version, but they also provide you services where you get everything done by them. And if you are programming your own software, you can also look into the L-DIH broker, which is a Node.js implementation that you can use in your own software products. I will mostly concentrate here on the database InfluxDB, because when you are working with sensor data, they most of the time series data, and so I will use InfluxDB. It's also open source. You can install it on premise or on the cloud as you like. It comes also with a small visualization tool. For the data collection, I normally use two products. One is Telegraph, which is a plugin or an additional service that you can assign to InfluxDB. It can connect to different sources of information. It could be a broker, it could be other messaging service, and you can use it to use the topic to build funnels to collect your software in InfluxDB. Or if you want it more universal, I can encourage you to look into Node-RED, which is an open source middleware, which you can use to collect, process, and distribute data in any way. It's a visual system, so it's a no-code system where you work with flows. Let's do a first look into it. So you may have seen it some minutes before. What is Node-RED? Node-RED is really this flow-based system. You have here on the left side a lot of nodes that represent functions that are injection and flow functions. Then you have functions where you can write your custom JavaScript code. For example, here I built a random temperature sensor that is producing data between 18 and 22 degrees Celsius, which is then emitted to an MQTT node on the topic fake device /random. That's what we have seen in the MQTT Explorer or in Shifter before. But you're very, very free what you want to do. You can also make HTTP in nodes where you can build your own API, or you can request data from APIs or from web pages and extract them and so on. You can transform the data, you can save it to files, you can even build simple dashboards, which I will show later. So for our case here, we emit something on the MQTT broker on a topic, and on this tab of the flow, I made an MQTT in node, which is subscribing to this topic. We can also do something like, you can also use white charts in MQTT. For example, now I would subscribe to all topics emitted by fake device / all white charts. If you want to use a white chart in between, you can use the plus, and then you can, for example, get from all devices. For example, you have a topic all devices, device name, temperature, for example, and with the plus in the middle, you can subscribe to all temperatures that are emitted to the topic, beginning with all devices. So in the next step, I get here the data. So let's look how they look like. So I start at here a debug node, and now we should get every 5 seconds the value. And you see, it's quite easy. It's a number value that is coming in here. So I will use a function node to get this payload. I convert it a bit. So I use this variable random temperature to store the temperature that is coming in, and I store a time, which is the current time of the server. You see also down here on InfluxDB, I can tag my data. So I have here a tag sensor and device, and with the name, random temp and fake device, I can later way easier find my data in the Influx database. And final step, I store our data from the fake sensor in our Influx database, which uses the bucket webinar, which is somehow database. If you compare it to Postgres, for example, that would be the database, and the measurement, that is more the table. So let's look into InfluxDB. So as said, it also comes with a user interface, a graphical user interface, and it's really powerful tool. It comes with a bunch of possibilities how you can get data in, and it helps you a lot with all the programming language native libraries that are available. It comes with examples how you can integrate, example videos, how you can integrate something into your project. And you can see it's also coming with plugins, and it's really a lot of plugins. And for example, if we search here, we find back MQTT plugin, and this in fact is a configuration for a Telegraph instance. But we can also look here for Modbus, and you see there's also a plugin to directly collect data from Modbus. Yeah. As said, the system is using buckets to collect the data, and here we will look into our first bucket. I will use here the Data Explorer to see what we already have stored. So you see again here, we have here our tag device, and I directly find, because there's not much devices here in this setup, I directly find the next tag, the device name I gave it, and then it already provides me the random data. We have here a graph, I press submit, and we have our first query. And you see here, the last couple of minutes, we have here some random data. We can also easily convert it to something like a gorge. So submit, and you see we have here the last value that we recorded. If you like this, and if you are okay with just some basic visualizations, then this is maybe already okay for you. Then you can collect your queries and your visualizations, and you can create a dashboard in the Influx. So here I prepared one with a graph and a gorge, and it should auto refresh, if I'm not wrong, every minute. Yes. So this is also a bit of dynamic. If it comes to collect data from different sources, I would recommend to you that you more look into Grafana, which looks quite similar. First time I saw the visualization of Influx, I thought, oh, now they integrated Grafana, but no, Grafana is a different project. And it's also open source. It has a bunch of features. It has also an alerting tool, which I will show you later also in the Influx database. And you can use their plugins. So there are, you can write your own visualizations, but there's also an enormous amount of plugins available. You can have even geolocalized data, which you can then display on a world map. But for the first easy visualizations, you can also use Node-RED with plugins or with the default means to build your own dashboards. The Node-RED dashboard has also some nice features, because it's not only, I have to change something on my dashboard, otherwise you see too much before. So I have to change something, and now I can show you. I now can show you a first simple dashboard that I built, again for our random temperature fake sensor, which is also showing here the temperature as a gorge and in a graph. Yeah, you see it's dynamic, it's changing whenever a new value is coming in. This has also some is also a good feature, but you can freely configure it in a very easy way. So you see, I again subscribe to our random temperature. I'm connecting there a line chart. I can configure the line chart. I can give it a maximum of amount it stores. This graph is not stored persistent, but on the outbound of this node, you can also connect a database or file, so you can replay on a reboot of Node-RED the data. And yes, it's quite easy to build here a new dashboard. But the big but is you can also add more functionality to your dashboard. You can use buttons, you can use drop-down menus, switches, and whatever. You can use color pickers to make inputs as well, which is not possible in the Influx database. And in the Grafana database, you also can at maximum show there an iframe of another dashboard that you use to control devices. So that's why I really like Node-RED, because it's easy to make a rapid prototype for any kind of system. So up to now, I showed you how we can build a device in Node-RED and how we can subscribe it to MQTT to receive data from the MQTT broker. I showed you how we can, again, better this way, subscribe to Node-RED to retrieve data from the MQTT broker, which we wrote back to the Influx database. I already looked into how we can build our first simple dashboard with Node-RED and as well with Influx. And in the next step of the webinar, we will look into our most favorite IoT rapid prototyping tool, which is called Kniwwelino. It was developed by us in a project called Be Creative for Kids, sponsored by the FNR, the National Research Fund in Luxembourg, in 2017. And its intended use was to make a first platform for children to teach them computational thinking. On the Kniwwelino, we have a Wi-Fi enabled microcontroller, the ESP8266, which has set a Wi-Fi capacity, which enable us to communicate also with MQTT. It uses a very easy block-based no-code development environment, which is running in a browser, so you don't need to install anything. And if you want to go further, it also is Arduino compatible and can also be programmed in Visual Studio or with the Arduino IDE. The Kniwwelino itself has on the front side also an RGB LED. It has a 5x5 LED matrix. It has 2 buttons as an input. Down here we have an I2C interface where we can connect more digital sensors. And down here we have some GPIOs for any kind of usage. So the first 4 are for digital in and outputs, and the last one is for analog readings. Let's look what we can do with it. So what we want to do is we want to create a software on the Kniwwelino, which is getting data from a sensor down here from one of the auxiliary ports. The Kniwwelino will show temperature value. It's a temperature sensor, of course. Will show the temperature of its display. So we use the matrix as a display. Then it will send the information to the MQTT broker, which we have a Node-RED subscribing to the topic of the temperature reading, and afterwards we could write the information back to the Influx database. In the second step, we will also first arrow was a bit wrong. We will also make some elements on the dashboard in Node-RED to communicate with the Kniwwelino via MQTT. So the Kniwwelino will also subscribe to some topics to receive informations from the Node-RED, which works as a server. So let's look into the Kniwwelino platform first. So here we see the Kniwwelino platform. It's a Blockly-based programming language. I already prepared some blocks for you, and I will explain in a second what we do with them. But first, I will go through the user interface. So normally it starts in simple mode, but we have here also an advanced mode for the experts, and which gives you a bunch of functionality to access all related to the matrix on the Kniwwelino. Then we have here functions to work with the buttons that are built on the Kniwwelino. They built in RGB LED as well as external colored LED strips or classical LEDs. We can, of course, work with messages, but also we have here classical blocks for conditions, loops. We can use variables to store things. We can use mathematical functions to work with the data. For example, if you want to convert it from degree to Fahrenheit and so on. Down here we have our section where we can add more sensors. And yes, so I prepared here a bit of code where I first configured the base topic. So all these orange colored blocks are related to MQTT message. And I first created a base topic, real device. I then connected two subscriptions, configured two subscriptions on the Kniwwelino. One is related to the RGB LED, which is subscribing to real device RGB color and real device matrix text and real device matrix icon. Here on this block, I also configured a private broker. So you can use the Kniwwelino with our public broker, but you can also connect it to private brokers. And I use the broker that I'm already using for the Node-RED examples here. I configured it. You see it's standard configuration with the port, username, and password. In the first step, we will create a measurement every 5 seconds. So I store the measurement from a sensor here in the temp variable. Then I will show it on the LED matrix as a number, and I will send it to the topic. Again, it's a combination of the base topic and the topic written here to the broker. In the second step, I will also attach this here to work with the buttons. So we have two built-in buttons that give us 3 states that it can be. So first state would be, or I call it third state, would be that button A and B is pressed simultaneously, that button A was pressed alone, or button B was pressed alone. And on these 3 conditions, the Kniwwelino emits either a 1, a 2, or 3 on the topic real device button. So let's prepare some more things on the server, because in the moment we only have this configured. So in the moment we only have this configured, and the dashboard is looking like this. So now I want to enable some more things on the Node-RED. And we add a second subscription for the real device temperature. We again will print it on a line chart, and we will display it on a gauge. but as well, I add here a color picker, which is sending to real device RGB color. You might remember I have here the subscription to real device RGB color, and I will subscribe to the buttons and show them as a text on the user interface. So, and if I do so and deploy this, our dashboard looks like this now. And in the next step, I will connect all the hardware things, and then we will try it. So let's show you how this looks on the Kniwwelino. So here you see the hardware. I already connected here a temperature sensor to D5. I've connected it to the 3.3 volt and to the ground, and the same on the sensor side. So I will power it up. It's now booting. And I will press the firmware upload button on the Kniwwelino. It will compile now shortly software, and you see it now downloading the software. This takes up to 40 seconds. And hope we have wired up everything correctly, but yes, it was D5. Okay, so now it rebooted, and you see that currently here in our premises we have about 27 degrees. It's also, I guess, it's more 25-ish, but I guess there's a bit of difference in the sensor. But if I now increase the temperature on the sensor, you will see that it starts to increase. So I heated it up by 2 degrees, and on our dashboard, I will just remove the camera. So now you see also on the dashboard that the temperature jumped a bit up. You see the prepared line chart is not well from the range. So I just increase it here by 2 more degrees, deploy again, close. And now we should have nicer readings. Reload the page. No, okay, it's still in the 30-degree range, but you can see that it's already going down. And if I heat it up again, it should decrease again, yeah, to 29 degrees. So I will just move the camera a bit so that we can see more. Like this. And I will now show you the way the other buttons we programmed in the Kniwwelino software. You remember we also programmed the buttons. So if I now press button A, the the 1 is shown here. If I press button B, 2 is shown here. And if I press both, you saw it shortly, button 3 was pressed. And now for the other direction, from the communication, I will now select here a color. And you see that the RGB LED is light up. It's a bit hard to see which color it is. I try to make it a bit dim, but it's quite hard. But you get that I pressed something reddish, and now it's more blue. And yeah, this is really complicated to see. It's maybe now you see it, it's green. So that was our live demo part. I hope you enjoyed it. And go back to the slides.
Well, thank you very much, Christian, for this very comprehensive overview of IoT prototyping. I see we have a question. Am I able to order Kniwwelino's?
I will answer.
Yes, Christian will provide you with the right address to buy the Kniwwelino's, because we have a spin-off to sell the Kniwwelino's. Okay, so we will deal with you. We will give you the contacts so you can buy them. Remember, if you want to use Kniwwelino, that the programming interface is totally free and it's online, and you don't even need to create an account. You just need to link your Kniwwelino with the programming interface for them to communicate, and it's totally free. So we are done for today with IoT. We have a workshop dedicated to these tools and to rapid IoT prototyping planned in a while, I must say, because it's going to be on March the 5th, 2026. But in the meantime, should you want to go further and have more information, then we will have a workshop on September the 25th here, at least in Belval, where you can learn about data acquisition, visualization, using kind of the same tools and soft that Christian showed you today. And this would be in German and French, I think, this workshop. And on October the 2nd, we have the data predictive maintenance workshop, where it will be more about the pipeline for data modeling and using Jupyter notebooks. So please, and it will be in March the 5th. So don't hesitate to register on DIH.lu. And if you have any question, please contact us.
Thank you very much to both of our speakers. It was a really good presentation. And yes, I see no more questions. So you can scan this QR code and you will land on our event page, where you can register for our future webinars and workshops that Laurence just mentioned. And the next DIH Talk, episode 9, will be on green tech, saving money through AI-assisted load distribution of electrical systems. On, I think it's on July 4th, if I'm not mistaken. So I wanted to say a big thank you for all of you for joining this webinar, and stay tuned for the next one. And I hope you have a nice day and a nice weekend. Thank you very much.